Hello everyone, and welcome to another episode with your girl Audrey Codner from ACCUPLACER Tutoring. Hopefully you guys are doing well this evening, this afternoon, maybe in the early morning. So what we're going to be working on today is distance formula as well as midpoint, and we're going to do a little bit of slope. So if you are someone that is thinking about doing your GED, ASVAB, ACCUPLACER, this is definitely the live for you. Okay, so we're going to do a little bit of intro, slowly going back into that linear functions. And we're going to take this just like I do each and every evening, step by step. All right. So if so, you definitely want to take heed of these two formulas for right now. One is the distance formula. So the distance formula, you have your x sub 2 minus x sub 1 squared plus your y sub 2 minus y sub 1 squared, which is underneath a square root. So it sounds very familiar. Just even what's inside the parenthesis. That should remind us what's going on with slope. Remember the change of y's over the change of x? So we're looking at how we're going to measure the distance from one point to another. And we just want to see what is the length of the distance. Not the gradient, but the length, okay? So how do we get from one point to the next? So let's get started. So over here, I have a nice little grid or coordinate grid for you. Let me zoom in just a tad bit. So what is going on? We have 2 points here. And let's just say that I want to find the distance from one point to the next. So I'm looking at possibly drawing a nice little line from here to here. And I want to find the length of that. So a lot of people, this is generally what some people do when it comes to test taking, especially when they're nervous. They're like, oh, okay, well, let me just basically say, okay, that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, the length of it is 8. No. So what you're basically doing is you're trying to make the length of this equal to its diagonal, which is not true. So this is almost like with you trying to get either a refrigerator in your house, or maybe you saw a big screen TV in the store and then you try to get it home and you're like, it doesn't fit through the door. All right. So we are only taking the measurements from one corner to the next. But what we really need to do is look at that diagonal. That's how you're figuring out, like, oh, I got a 64-inch TV. It's not 64-inch from here to here. We're looking at more so that diagonal. So this is why I know a lot of people that are movers, they're just like, every time we try to move any kind of refrigerators or any kind of large pieces of furniture like couches, people have problems because when they measure, they don't necessarily measure the door. They measure from here to here. They don't measure like on the diagonal. So that's why you should always measure. You may love the style, you may love the flair, but make sure it can fit through the door. Because, you know, having a brand new couch sitting outside on the porch with the elements, not so much fun. Not so much fun. All right, so not a problem. Not a problem, Scott. So if anything, we need to get the coordinates of these 2 points. So for point A, if we recall, we have our y-axis, which goes up and down, and we have our x-axis, which goes left to right. And if we want to get order pairs, we always start at the middle, which is our origin. That's our 0, 0. So when we try to coordinate a point, we're looking at the x, then the y. Okay, so we're starting here, and for me to get to point A, I have to move to the left 2. If I'm moving to the left 2, that means I'm dealing with my negative numbers. So here's my -1, here's my -3, there's my -5. So right here, I'm at -2. So from here, I need to go up. So if I'm going up, I'll go up 1, 2, 3, 4, 5, 6. Okay, so this was my +5 right here. This is my +1 right there. Okay, so to name your coordinates, you start at the 0. In this case, I wanted to go to point A, so I went to the left 2, that makes it -2, and then I went up 6, which makes it a +6. So we're going to do the same exact thing for point B. So now for point B, again, we're going to use our X, then our Y. So that means we're going to start at the origin, which is at 0, 0. Then we're going to go to the right, because that's where point B is. 1, 2, 3, 4, 5, 6. So my X value is 6. And then we're going up 1, 2. My Y value is 2. All right? So now that we have the coordinates, I want to know what the distance is from here to here. Now, if you're doing advanced math, a lot of people will say, all right, Audrey, well, you can make a right triangle and you could solve it by Pythagorean theorem. Okay, because that sounds a little familiar. So I'm actually going to solve it both ways. Okay, so you can see where the origin of all this stuff is coming from. But right now I want to start really simple-ish. So we have 2 points here. So I'm going to move this over just a little bit and rewrite my points. So we have point A, which is at -2, 6. And we have point B, which is at 6, 2. So by looking at this, normally, this is how we read. Normally us here, we read from left to right. And I know there are some countries that reads from right to left. But I'm going to go from left to right, just so everyone understands. So since we go from left to right, and if you think of the order pairs, your X comes before your Y. Point A is going to be my first point. So since coordinates always comes in X then Y, this is going to be my first point. So that's 1 and a 1. The subscripts of the 1s means that this is the X and Y value of the first point. Now I'm going to go to point B. So if the subscript for point A is 1, what do you think the subscript of point B is going to be? It's going to be our 2's. Okay, it will be our 2's. So we have our first point, we have our second point. So this is when the formula is going to kick in. So if we want to find the distance, remember the distance formula is our square root of our difference of our x's, so that's x sub 2 minus x sub 1, and it's squared, plus the difference of our y's, which is y sub 2 minus y sub 1, squared. So all we're going to do is take the information that we have up here and substitute it in to our formula. Okay, so my x sub 2, that means it's the x value of my second point. So that will be a 6. Minus the x coordinate of my first point, which is a -2. Okay, and it's going to be squared. I'm going to try to put everything in. Now, we have our y values. Y sub 2, that's 2, minus the y value of my first point, which is 6. And we're going to square it. Now I'm going to put my square root over top, because I really want you to see where this is coming from. All right? So now, let's do some like terms. Let's combine some things, make it nice and neat. So we have 6 minus a negative 2. When you minus a negative, it turns positive. Okay? When you minus a negative, it turns positive. So now we have 6 plus 2. So that gives me my 8 squared. Plus, now we have 2 minus 6. That gives me my negative 4 squared. Because 2 minus 6 gives me negative 4. So now let's clean it up some more. So 8 squared, that gives me 64. Okay, plus negative 4 squared. Okay, please do not say it's negative 16, because negative 4 squared is negative 4 times negative 4. So a negative times a negative will give me a positive, and 4 times 4 will give me 16. Okay, so now let's clean it up some more. Okay, so now we got 64 plus 16. That will give me 80. Excuse me. I've been dealing with these allergies all day today. My goodness. Switch up. So now we have the square root of 80. Now, square root of 80, there are factors for that. So, come to my handy dandy notebook. Gonna see what we got for 80. Okay, 80 is down here. So I have 1 and 80, 2 and 40, 4 and 20, 5 and 16, and 8 and 10. So my perfect prime combination of breaking down this radical is going to be 5 and 16. 16 is a perfect square root. 5 is a prime number. Yes, you can use 20 and 4, but you're still going to break down to 20 with 4 and 5. Yes, you can do 2 and 40. You can break down the 40 with 5 and 8, but then that 8 needs to be broken down. Or you can break it down with 4 and 10. All right? So either way, I think this one's going to be a perfect combination. So when we break it on down, I'll put it in red, we have the square root of 16. I almost forgot what I was. 5. Almost forgot what it was for a second there. Here we are. So if I clean this up, my distance from point A to point B is going to be 4 square root of 5. And I know there's going to be some people like, oh, Audrey, well, shouldn't it be plus minus? Well, right now, we're not solving. We're basically looking at the distance, okay, from one point to the next. And since it's going to be distance, we're going to be looking at the positive of it. And we could just say units, because I didn't give any markings for inches or feet or any of that. Okay. All right. Okay. So, going from one point to the next, we're basically using what's called our distance formula. But if you recognize it, bits and pieces of other formulas is mixed in here. And the process of it is also mixed in as well. So we could use this y sub 2 minus y sub 1 squared plus y squared, y sub 2 minus y sub 1 squared over the square root to find the distance from point A to B. But there is another way of doing this. So as I mentioned, a lot of people, when they measure to bring things in their homes, they just measure from one end to the other. They don't worry about the diagonal. But I know I could make a right triangle from this. Just based off of the points that I have here, I can figure out how long it is from here to here. So if I'm starting here at the x value at -2, and I'm ending at my x value at 6, I know from here to here is 6 plus 2 more units will give me 8. So the length of this side is an 8. If I want to go from this point to this point, just on this edge, little vertex going on here. All right, if I want to go from here to here, I'm going to take a look at my y values. Right here, my y is starting at 2. And I want to go up to here, which is a positive 6. So if I go 2, 3, so this will be in 1 step, 2 step, 3 step, 4 steps. So from here to here, it's going to be a 4. Knowing right triangles, we got something that will help us with it. Do you guys remember what it's called? Begins with the letter P. Maybe the spelling is going to be all kinds of crazy. Yes, Pog, yes. There you go. Okay, yes, Pythagorean. Good job, Daniel. Good job, B. User, yes. Ian, good. All right, so we're going to have that Pythagorean theorem. Michael, where have you been? Missed you yesterday. Okay, so Pythagorean's theorem, okay? We all know it. Sometimes we have this memorized in our brains. Back underneath all the teenage angst, all of a sudden comes out that a squared plus b squared equals c squared, right? So your c is your longest side, your hypotenuse. The easiest way to find that is we find your 90 degree, the side that's opposite that 90 degrees, that is your hypotenuse. All right. So when you have the other two sides, they're called the legs. So if I take the square and I sum up both of the legs, it should equal the square of my longest side, the hypotenuse. Keep that in mind, okay? Keep that in mind and take a look at this one right here. All right, just keep that one in mind too. So when it comes to the Pythagorean's theorem, I know I feel like I'm just like chatting away, but we got to get through all this. So this, the length that we were looking for, that's my hypotenuse because it's directly across from the 90 degree angle. So that means this side length of 4 and this side length of 8, they're my two legs. Now, the best thing about Pythagorean's theorem, that it doesn't matter which one's your A and your B because they're interchangeable. But the hypotenuse has to be your longest side. And that's what we're looking for. So if we I'm going to come a little bit down about here. And I'm going to say, all right, let's say my 4 is my a squared, plus my b squared will be my 8 squared, and it's going to equal my unknown, so that'll be my c squared. 4 squared is 4 times 4, which gives me 16. That sounds familiar. 8 squared, 8 times 8, which gives me 64. And that's going to equal my c squared. 16 plus 64, that's 80. And the way that we get rid of a square is doing its inverse, which is a square root. It's up there a little bit. So now, square root of 80, we did that already, right? Remember, it was 16, and 5. 6 looks a little crazy. And the square root of c squared, the square and the square roots, they're inverses of each other, so they cancel out to give you c. And then what's left is 4 square root of 5. So the length of that side is 4 square root of 5. Does that sound familiar? Okay? Yes. So, the one thing that I keep hearing from a lot of people, especially when they take any of those tests, the GED, the ACCUPLACER, the ASVAB, one of the things they worry about is time. Now, and also memorizing all the formulas. And trust me, you're not going to remember all of them. You're not. You know, you got to give yourself grace. Familiarize, I can't even speak. Get familiar with it. Get familiar with them. But at the same time, if you can cut out basically one formula, because you know you're going to see Pythagorean's theorem again, why not, when they ask for the distance, make it into a right triangle? The way that you get your lengths, hey, you can either just count the dots. And don't start at A and say that's 1. No. Go with the motion. The motion, that's 1. That's 2, 3, 4, 5, 6, 7, 8. That means the length of that side is 8. Then you come here. Go 1, 2, 3, 4. That's the length of that side. And since we are very strong with a squared plus b squared equals c squared, you're basically finding the c each and every time. Okay? All right? So yes, it's great to have the formula for the distance formula. All it is basically a twisted, how should I say? It's like having like your favorite lemonade, but then people try to put too much stuff in it and you're like, ugh, like you ruined it. Or it's like, okay, it's nice, but I just want a regular lemonade, like a really nice drawn lemonade. And then all of a sudden someone comes out with like a mango flavored lemonade and you're like, ooh, yes. That's nice and refreshing. All right. So it's nice to know, but it's not necessary. So as long as you know, regardless of how long it is, you can make a right triangle out of it and do Pythagorean's theorem. Okay? All right. So let me see if I can put another one up here, because I did not know how much space I was going to take. So, whoops. And then plus to see how you guys are doing as I'm setting up the next one. Cut and paste. Gotta love it. All right. Makes us do the math for the square. Yes. Yep. I lost you. Okay, when did you come in? Marina's. Nice. Whew. Okay. All right, let me scroll through all the comments because I know I was just hammering on. All right, okay, so last time I got was Scott. Hello, bundles of blessings. Welcome in. Okay, yes, Swift, good job. It's paced to understand. Thank you, Scott. Appreciate that. All right. Yep, it's basically the derivative. This is mind-boggling for real, okay? All right, so we got this with the positive, boggling for real, okay? All right, so we got this with the positive, coming in with the 80. Where is that book from? It is actually Alex's a book that I designed, and the website is in my profile. Yep, so I sell these, and I also sell the notes, not today's notes, but I have the notes from when I first started, which was February the 5th. So I am finally getting myself self-published. And I guess my thing was moved over too much. Oh, yeah, after those vectors, not doing that. All right, thank you, people, for telling me. You're just learning the unit circle. I know. And the parts of this K is in those unit circles. So, yes. Pythagorean theorem. Because basically that's what you're doing. You're extending that. All right. Well, thank you, Divine, for saying I'm doing great. But less than hypotenuse. We would hope so. Yes. Okay. I know. So this is what happens when we do stuff. Okay, in the relationship. I know, I try to put things in. All right. Hey, Danny. Okay, not today. All right, so let's zoom in. I just wanted to make sure I wasn't missing too much. And I know some people came in here and they're like, what is this? I'm just used to someone just saying, hey, you know, is the answer 4 or -4? And it's always just like, you know, order of operations. But for me, I like to do a little bit more teaching. The reason why I do this is to, one, help people get over their math phobia. At the same time, I really want to help people if they're thinking about taking the ASVAB, their GED, or maybe just help them build their confidence with math. That's basically it, okay? So welcome on in. If you are new to me, go ahead and follow if you want to follow. And if you can't stick around, but you're just like, oh, I really like this, I really need this, all of my replays. Ooh, let me unzoom that. Okay, all of my replays. Ooh, let me unzoom that. Okay, all of my replays for my lives. If you subscribe to my YouTube channel, just go to Audrey Codner at ACG Math Tutoring. Just type in Audrey Codner, you'll see it. There is a playlist that I have for my TikTok lives. So right now, I'm pretty much up to date. Last night's I actually was able to put up on this morning, but this one may take me a little bit longer, but it will be up there. Okay? All right. So let's get to it. So we have a lovely, okay, going into the negative direction from left to right. So you can basically make your triangle either from the top down, or you can use your Y and X axes to help you along the way. So me personally, it really doesn't matter, but I kind of like using the Y's and X axes a little bit, because then I can see my numbers a lot clearer. And then this right down here, that's going to be my 90 degrees. So that means the side that we're looking for right here, that's going to be my C. So from the origin to this point, that looks like 5 units. And from the origin up to this point, looks like 3 units. Okay? So now, oops. Remember about square roots? Okay. All right. Okay, blue girl, we're going to get you together. We're going to get it. We're going to get it. Yes, math phobic, trust me, it's okay. It's okay. I am a former addict. I'm a former person. So if you take a look and for some reason you can't see it on the grid, you can retrace it off to the side. But right now, my two legs, the 3 and the 5, they're interchangeable. And what we're going to do, let me see if I can stop moving stuff around. We're going to be using Pythagorean's theorem. So Pythagorean's theorem says a squared plus b squared equals c squared. Okay? Your a and your b, they're going to be the legs. Okay? So it doesn't matter which one's a and which one's b. We're going to end up in the same place. So let's say my a is 3, so I got 3 squared. Plus my b, that will be my 5 squared. And that's going to equal my c squared. All right. So we'll have 3 squared, that gives me 9, plus 5 squared gives me 25. What would we get as a total for C? Let's see if we can step this up a bit. What would be my C? Put it in the chat. Okay. Okay. So if I add these up, what would I get? All right, so C4 is saying 34. Oh, stay Maddie. That's funny. 24. Okay. Hydrate. Oh, here we go. Hydrate mom 34. Square root of 33. Oh no. Okay, 34. Danny says 68. 34, 34, 34. Square root of 34. Okay, root 34. Got it wrong. Okay, go ahead and make your adjustment. See, this is one thing you'll learn about over here. This is not, Squid Games. You're not going to get kicked off or X'd out of life in order to get that done. All right, so K. Grundy, good, 34. So when we add these two up, we got our 34. And that's going to equal our C squared. But in order for us to get rid of the square, we have to do the inverse. The inverse of a square is not a circle. It's a square root. I actually had a student told me that. And I was like, seriously? Okay. Now, we got the square root of 34. So square root of 34 equals our C. Square root of 34, can that be broken down? Oops. Last time I checked, 34, only factors we have is 1 and 34 and 2 and 17. And all this, 34, the 2 and 17, those are some primes. So we can't break down that radical of 34 because we can't get anything perfect out of it, okay? So we leave it as a radical. And you're probably thinking like, oh, okay, well, I got to do something else. No, you don't. That's it. You want to find your length. Your length of it is going to be the square root of 34 if it's the exact answer, okay, whatever their units are. But if they say it's in decimals, that's when you're going to take your handy dandy or whatever calculator they kind of give you. Majority of the time, they're going to leave it like this because most of those examinations, you will not be able to use a calculator for. I know as ACCUPLACER you won't be, ASVAB you won't be. In GED, they might pop in a calculator here and there, but it won't be 20 the whole time sometimes. All right, so We got our square root of 34, just in case they do. Let's say we want to round this. See, we got to get some practice with rounding as well. I want you to round this number to the nearest thousandth. TH at the end with the S. Lots of spinning. Okay. Like, nope, right? Okay. What would this be to the nearest thousandths? Put it in the chat. Okay, so Daniel is saying 5.831. T is saying 5.8. Bundles of Blessing 5.831. Michael R 5.831. Lincoln 5.831. Pog 5.831. Keith 5.8310. Okay. C4 5.831. Hottie B 5.831. Geo. Hey Geo. Haven't seen you in a bit. Juliana. Okay. VHM 5.31. Okay. K Grundy 5.831. Okay. RX Papa 5.831. Thrill Me 61 5.831. There you go, VMHN. All right, good. All right, so 3 digits when we talked about the thousandth. Remember, this is your tenths, this is your hundredths, this is your thousandth, where that 0 is. In order for you to round, you need to look at the 10,000ths, which is that 9. Okay, if it's 5 or more, 5 and above, so that means 5, 6, 7, 8, 9. If it falls within there, that means you're adding 1 to that previous spot. Okay, if it happens to be a 4 or below, so that means 4, 3, 2, 1, 0. Okay, that means you are not adding anything. You're just dropping everything off to the side and just leaving it alone. So if we wanted to, I'm going to put the or, and right next to it have your 5.831. Okay. All right. How are we with distance formula? Does making it into a triangle, is that a lot easier than trying to remember the distance formula? Talk to me. Okay. So Michael's saying yes. Tanya's saying yes. You have a question? Yes, Danny. Ask your question. Okay, Danny, yes. Good. Bundles, yes. Same. About the same? Okay. What about the 90-degree angle? What about the 90-degree angle? So the 90-degree angle is just helping us to identify that this is our longest side. So we're just using it. Just like my ex. Just using it. Right? Good. Yep, it doesn't do anything to it. Nope. We're just using it just to identify, to say that, okay, this is my longest side. We're dealing with right triangles, so that means I can use Pythagorean's theorem. All right. Okay. Would you like to see one more with distance formula, or would you like to move on to midpoint? I'm actually giving you. Clutching the pearls. Hey, that's my life. Yeah, it is a time saver. That's true. Move on. One more. Yes, please. Feel like VHM, you're getting ousted. Right now I got 2 responses. And I know, usually Michael, I'm surprised Michael didn't chime in yet. He's Mr. One more time. Okay, let's see. There he is. Okay, one more. And what I'm going to do is I'm going to tape it up here. And then I'm going to leave you alone for about a minute. I want to say like about a minute. Because I think we're getting faster. Especially for the old G peoples that's up in here. And then, Michael, your books should be coming in 2 weeks, believe it or not. Trust me, it has been a bear. But I will be having those in my possession so I can give it to you. All right. So, give it a try. Let me see if I can really zoom in so you guys can do it. Give it a try. First thing, here's the hint. Make your triangle. Do I teach physics? I do not, but I do know some people who do. So Britt, if you're serious about you need help with physics, I got another person. It's not a guy. Got another person. Okay. Okay. So Jenny, breathe, relax. So if not sure, see if you can make a right triangle out of this. If we can get to that step, you got it. Okay? And if you get something wrong, guess what? We'll move on. We'll make a correction. It's okay. I'm not grading it. Hello, Bella. We are basically going to make a right triangle, use Pythagorean's theorem to find the length of this black segment. Okay. Hey, notification. How are you? Okay. You can do some coordinate points. You can definitely do that if you wish. Okay. Okay, keep going, notification. Keep going. Let's see some coordinate points first. Actually, you don't really need. See if you can draw it out. If there's no intersection. Well, we're not intersecting. You can make a right triangle out of this. Let this be your hypotenuse. Let the segment be your hypotenuse. You can do rise over run. That'll be your slope, not your distance. That's how steep your line is. Yep, rise over run. Yep, we're going to talk about that tonight too, as well. Yeah, it's going to be a nice, relatively nice long one. I mean, are we going to be going to like midnight on the East Coast? No, not that much. But we are going to do something. Okay. Okay. It's a little confusing. Okay. Well, relax, because this is what we're going to do. We're going to be going over it shortly. We're going to see what other people got. And then I'm going to break it down step by step. All right? I'm never going to just like, oh, there's a person who got the answer. Yay, all right, that's done. And we're moving on. No, I don't do that. Okay, I look at what people have. So if you haven't posted your answer yet, go ahead and put it in the chat. And if you're not sure, remember, question marks are encouraged. That's perfectly fine. Okay, remember, we didn't come out the womb over here speaking. No, we were just like, what the hell is that? Oh, it's a finger. Okay? So, okay. All right, so we got some roots. Got root 52, root 65. We got radical of 65. Okay. Yep. And notification. I will be starting a summer prep course, starting all the way from the very beginning, like all the basics. Okay, so Rico's saying a squared plus b squared equals c squared. Yes, that's what we're using. Yes, we are. All right. So, let's try it. So, if and when, and some of these exams does exactly this. Where'd my pen go? Here we go. I feel like I have so much time saying, where's my pen? Where's my pen? Where's my pen? So if we want to, we can make a right triangle. We could either make it from up here going down, or we can make it down here going over. Doesn't really matter, okay? You're going to get the same exact answer. So if I wanted to, I can go from here to here and from here to here. Notice I made a nice right triangle. And I'll actually use one of the blocks for my right angle. So the right angle, the side that's directly across from that right angle, that's your hypotenuse. That's your longest side. That's what we're looking for. So now we need to figure out what the lengths are for these two sides. So from here to this point here, it's 1, 2, 3, 4. Just count the blocks. Got 4. So now from here to here, we just count. 1, 2, 3, 4, 5, 6, 7. So the length of this side, which is called the leg, is 7. So one side is 4, the other side is 7. So now we're going to use Pythagorean theorem to find the length of this side or this segment. Okay? For those that were lost before, how are you feeling now? Okay, we're feeling all right. Thank you for the follows and the shares and the likes. Okay, good. Tanya, good. Thank you. Because if you're not, let me know. I'm here to break it down. Okay? It takes a while to break down years and years of being told that you are dumb and you can't do something. You can. I'm living proof. I used to suck at math. Okay? All right. Hey, Janice, how are you? All right. So now, let's get into it. We got our a squared plus our b squared equals our c squared. The c squared is the longest side that we're looking for. Oops. So, the legs are interchangeable. It doesn't matter which one comes first. Now I'm going to switch it up. I'm going to say, okay, then this is 7 squared plus my 4 squared equals my c squared. 7 squared, 7 times 7 gives me what? Okay, no problem. So after we draw our triangle, all I did was count from one point to another. So it seems like they're meeting right here. So I go down 1, 2, 3, 4. Then I go back to that point. Then I count over 1, 2, 3, 4, 5, 6, 7. Okay, whole bunch of 49s, 49s, 49s. Okay, so we got our 49 here, and Danny gave us the other one, which is our 16. Good. All right, how are we feeling? So if we got our 49 plus our 16, that gives me 65. And 65 is equal to c squared. So in order to get rid of the square, we have to do the inverse, which is our square root. Squares and square roots, they're inverses of each other. So now we have the square root of 65. And that's going to equal our c. So if I want to take a look, let me see. Is there any factors for 65 that can help us out? We got 1 and 65, and we got 5 and 13. Nope. Okay, got some primes in there. So we don't have any perfects that's in the mix of 65. Okay, you can't do 25 because that will give you a decimal. So if we can't break it down, we just bring it on down. So the length of that side is the square root of 65's, whatever the units are. Okay. Yes. All right. Not a problem. Yay. Okay. All right. So that is basically, I created this book. I got tired of my students not having notes. So this is one of 3 versions. I did self-publish early this morning. Yay, yay. Your girl has her own bookstore. And I just basically try to keep all my notes in here, try to organize it so you can have the formula on one side and the steps on the other side. I'm not sure. It's a new thing, so I like to get the first sample to see if it is up to my snuff, because I don't want you to invest money into something and it's just subpar. That's just me. So hopefully once I get my first book, it's going to be a couple weeks. I know. But I do have the updated version of my Audrey's notes. So all these notes, I actually sell them. So in addition to the notes, I'd put, let's say for example, this will be the cover of it. And the notes would look just like this, just like what you see before you. But what I do is I put a QR code on each of the notes, and that will take you directly to the live that is connected to these notes. So I have all of those. They're up and running on Amazon right now. I just had to put the links on my website. I haven't had a chance to do that because I've been tutoring like a crazy woman today. Yes, my life. Okay, but go ahead and click the link in my bio for Ultimate Math Notebook so you can get your copy of the notebook. And in addition to the factors, because I know that's the one thing a lot of people like, it doesn't just go from 1 to 100, it goes all the way up to 200. But it also has like your order of operations, your properties of exponents, some of the properties of quadrilaterals for geometry. It has your volume and your surface area, your sectors, arc length, unit circle. I know people are cringing right now. And then also the Pythagorean theorem, and we have the SOHCAHTOA, and then also the other trig identities as well. So all this wrapped up in one. It's 100 note pages altogether. And for some reason, I just won't be able to put it on TikTok for a bit. So that's okay. Yeah, I just got rejected. I don't know. Maybe it's something I said. Maybe it's all this greatness. I don't know. But that's okay. We're here. Okay. So, yeah, if you want to support, if you need it for this year, need it for next year, maybe need it for the summer, because I will be doing a live summer course. I finally decided that I'm going to start it on June the 8th, and it's going to be at 8 p.m. Eastern Standard Time. And I'm going to do it twice a week on Tuesdays and Thursdays, but I will be putting announcements out for that. Just to see, and we're going to start from the very beginning, and I'm hoping to get you guys ready for the fall if you're thinking about going back to school for anything, or if you're trying to go back for the ASVAB and so forth. All right. Okay. All right. Okay. So, not a problem. So now we're going to talk about midpoint. So I'm going to see if I can pull, now that I have like all the stuff in my way. If I was given 2 points, So I'm not going to graph it, but I'm just going to give it to you because this is what they do. So here's our example. They give you 2 points. 1 point is at 6, 0, and another point is at -4, 2. And they always do the midpoint without a graph. It's weird. I don't know why, but they just do. So they want you to find where in the middle. So this is going to be one endpoint. This is going to be another endpoint. And what is the middle section? What is the midpoint for between these two? That's on supposedly the same segment. So instead of you drawing out a grid, because I know that's our natural habitat, let me see it because we're visual, there's actually a formula. Really simple, really easy, to the point. So if I may, I'm going to take the x's, not my x's, but the x's of those 2 points, add them together, and divide by 2. Think about it. If you wanted to find the average of something, or basically the mean, you would add them up and divide by the number of numbers, right? Kind of along that path. Or actually, what would be better if I wanted to find the median? That would have been a better example. If I wanted to find the median and it was stuck in between 2 numbers, you would add those 2 numbers up and divide by 2. Same thing is happening here. You're just putting your x's together. Then, I should not put my x's together. Wow. That will be a nightmare. And then we put our y's together. Add them up and divide by 2. That's how you would find the midpoint. It's that simple. I know. Okay? So in this particular situation, if I go, and it doesn't matter really because you're adding, okay? So that means I will have 6 plus -4 divided by 2. And then I would have 0 plus 2 divided by 2. For us to find that coordinate. Okay. So right now I'm finding the midpoint of segments. Are my x's and x's? No. That would be even funnier. A little further out west. East Coast girl, West Coast boy. Yeah, no. Okay. So, Nurse. Hi, Nurse Green. How are you? Where did the 2 come from? The 2 came from my y value. Okay, so I'm adding my x's, which is 6 plus -4, divided by 2. Then I'm adding my y's, 0 plus 2, divided by 2. Okay, all right. So now, let's put it all together. So 6 plus -4, that gives me 2. 2 divided by 2, that'll give me 1. 0 plus 2 gives me 2. 2 divided by 2, that also gives me 1. So the coordinate 1, 1, that's your midpoint. Okay, someone said it earlier. Sorry. Yep, Daniel said it earlier. Michael R. said it earlier. Thank you, guys. All right. Okay, so Stephanie, do you see it now a little bit? Okay, Michael was guessing. So Stephanie had a question. All right. We're doing other formulas throughout the live. I've just joined. I have one more formula after this. Okay, one more formula after this. Okay, so let's give it the old college try. All right, let me unzoom a little bit so you guys can see. That's the one thing. I wonder if you guys get seasick with my with my lives. I'm zooming in, I'm zooming out, I'm zooming in, zooming out. Okay, just like I was in class. So let's try this. Let's try 7, 3 and -1, -7. And we're just finding the midpoint. So the easiest way I can say, add the x's divided by 2. Add the y's divided by 2. Treat it like it's an ordered pair, and you'll get your final answer. I try. Show it in real world application. Ooh. How sultry can I do this? Okay. Real world application. Okay, so it's a group of friends. Wait, should I do it that way? Let me think it all the way through, because I don't want TikTok banning me and all of a sudden I'll be shunned for the rest of my life. And then I have to explain to people why I got shunned from TikTok for the rest of my life. All right. So, if we wanted to, we have these two people that are in groups. Okay, 2 sets of people. So here's a couple, here's a couple. All of a sudden, this person and this person decides, you know what? Let's stop this feeling. Let's get together. Let's get together. And they're like, well, you know what? If you guys are going to get together, then we're going to get together. But now that we're together, you know how when relationships start, we have to do this great thing called compromise. When you start splitting things up, like it doesn't make sense to have 2 microwaves in one house. How much popcorn do you need? All right. So you're dividing your items up. Then you realize, hey, things are working out pretty well. Because 7 in the beginning was kind of rough, but 7 plus -1, that gave me my 6. Then we finally decided that we have to take half. When you take half, that gives you your 3. Then over here, hey, things were kind of working kind of crazy with us. Nope, -4 divided by 2. I needed to take away this person and take away half the information. Now I got a -2. So my ordered pair that came out of these 2 toxic relationships was baby number 1 and baby number 2. The end. I know, it was nothing like what you thought it was going to be. Okay. Hey, you're back home? Oh, you're back home? All right. All right, show me a reason I need to know this. Now, here's my thing, and I say this every live. I don't know what you want to do with your life. I don't know you. You don't know me. I've never been to your house, never been to my house. I don't know what your hopes and dreams are. But as life keeps going, math keeps evolving. Like, there is more and more math applications that's happening each and every day. Just because you don't walk around talking about, oh, okay, let me divide this and divide that. Now, if you're thinking about like, okay, I got all this pizza or I got all this food and I want to split it amongst like 4 kids, and how can I do it even? Because you know, if you try to give one kid one piece of candy more than another kid, enough said, okay? So you always want to do that piece. Same thing with parents, okay? Older parents, I swear, I think they go backwards in time. Now they're acting like little kids. You're like, okay, I gave dad this. Why'd you give your father that? How come I didn't get that? What's going on? I'm like, oh my God, you both live in the same house. So it's just always like some kind of weird thing. So when it comes to math, I know there's a lot of math applications. There's a lot of apps. There's a lot of computer bases that's happening, and they're not necessarily doing handwritten mathematics. But by learning to think outside the box and be able to apply things when you're asked, it's better for you to say, oh, I've seen that before. Can you just reintroduce that versus what the hell is that and where is that coming from? Because that's not going to make you look good. So I try to teach as much math as possible so you can apply it, so you can try to put into something. Because guess what? Making a decision, that's math. Your process of how you get up in the morning and get ready for your day, that's math. Just because it's not out and out as an equation doesn't mean that math isn't happening. So again, I just want you to learn as much as you can, savor it, value it, because it's surrounding us. Okay? All right. You have 3 kids, your math ain't mathing. I know. And you try to even those things out. Where did it come from? Ooh, and your name is Harry Tubman. I cannot. Should I say, wade in the water? Wade in the water, children, wade. Okay. Harry, it was before your time, girl. Oh my gosh. All right, so get closer to calc. Yeah, we're not. And knows to help with college algebra and, well, yes, I do. With my Audrey's notes, they definitely have a lot of polynomials, adding, subtracting, multiplying, and dividing the polynomials. That's in there. All right. You left math behind. Okay. Thank you for explaining that. Not a problem, because it's hard. I understand. It is challenging because when we first experienced math, no one took the time to say, hey, this is why this is happening. It was all, here's a formula, shove it in your face, memorize it, and then regurgitate that back to me for the test. And if you don't do well on the test, that means you're stupid. And guess what? You're not stupid. We just didn't walk around everywhere we went talking about square roots. And that's where it all stems. And this whole thing called math phobia is throwing people off. And then you're living your life in the rightful age of the 20s, the 30s, the 40s, 50s, 60s. We do have 70s and 80s in here. Hello. With all of the fabulousness. Still to this day have fear and anxiety about math. All because of what happened to you at the rightful age of 5 and 6. Isn't that crazy? Holding on to the day we're about to pass on to meet our maker, right? So I don't know if he's speaking through me or what, but I just feel that we just need to take a breath, and you can understand this, okay? We just have to take it step by step. If it just helps you to think clearly and be able to kind of, just relax. Give yourself grace, okay? You got this. Because if I can learn this and teach it, anybody can do this. It took me 11 times to pass in math praxis. Please, we got this, okay? Now, and what is this? We already did the distance formula. We figured a nice, easier way to kind of do it. All right. Midpoint, we just add up our x's divide by 2. Add up our y's, divide by 2. Once you simplify, that's your answer. That's it. Okay? All right. Oh, well, thank you. I mean, and trust me, math can be fun. It's just the whole thing, especially like if you're one of those type of, well, I'm one of those type of females that is like a detective. Maybe this is why I'm divorced now, because I was like, so is like a detective. Maybe this is why I'm divorced now, because I was like, so you said like about 5 weeks ago that, oh, all right. I thought like there's like you said about 5 weeks ago that you did X, Y, and Z. And like for me, I will show all the facts. Like, would I whip out the receipts? Yes. Would I pull out a PowerPoint? Probably. But we'll talk about my psychotic self a little bit later. So, F1, yes. FBI Audrey, yes. Yeah, because I married a man-child. That's why. Yes. All right. So, we're done with this part. The next part is the piece that every kid, man, woman, child, all gets crazy about. And I'm going to show you step by step in just 2 forms. Okay? I'm just doing 2 forms. A lot of people know it as rate of change. But all of us knows it as slope. Okay? We know it as slope. There are songs about it. People are just raving about it, losing their minds, completely out of the ordinary. Yes, there are songs about slope, believe it or not. I ain't singing it, but you know, there we go. One thing that we need to know about slope, and I'm going to put it in my formulas. There's a couple of them. I know it for the change of y over the change of x. I'm going to zoom in a second. So prepare yourself to be warped over here. Something is going on. There we go. Here we go. All right. So slope is the change of y over the change of x. So a lot of people will know it as your y2. They always say this. y2 minus y1 over x2 minus x1. Other people know it as rise over run. Okay, someone mentioned that earlier tonight. So rise, either you're going up or down. Up if it's positive, down if it's negative. And the run, you're either going left or right. Left if it's negative, right if it's positive. Okay? If we can recall, and the letter that they're using to represent is M. Why M? I don't know. I don't. Okay? But we're going to work this through together. Yes. Okay? We're going to work this through together. Type M, everybody. Yes. If you want to type N, knock yourself out. So, what slope is the steepness. How steep is your graph? So I have one graph here. And we're going to find the slope. I'm going to put it more towards the side because I want to do something else on that side. So we talked about distance. So distance really dealt with the length, whereas slope deals with the gradient, how steep the line is. So if you think about it, we're going to be traveling soon. Hopefully you guys are going somewhere fabulous, right? And if you're going by plane, your gradient will be as you're taking off, how steep. Because there's times when you see planes taking off, I see it almost like this. I'm like, are y'all trying to go to the moon? What is happening? All right. So some of them is going to be a nice little incline. Some of them is going to be more of an incline depending on what the flight pattern is. Some of you guys might be traveling by car and you might have to go through an overpass, like go through a mountains pass. And you'll see those signs with like a little car and it'll give you like a degrees. They're talking about the gradient that they're about to experience with that mountain pass. If it's snowing, do they need to pull over to stop, put snow tires on or put chains on and all this other stuff. So it kind of tells you a little bit about what's coming around the bend. Just around the river bend, right? So by looking at this, you have basically 4 different types of slopes. All right. So the first slope is a positive slope. Okay. It's positive when your x values are increasing and your y values are also increasing. So as the x's are increasing, your y values are going up. The other ones are called your negative slope. So that's when your x is increasing, but your y's are decreasing. So as my x's are increasing, my y's are going down. Just like our example right here. Another one is our zero slope. A lot of people like to call that your horizontal. So for your horizontal, it's only your y's. It's only crossing over your y-axis. Horizontal, horizon, right? When you think of the horizon, just a little cusp of it. Okay, that's going from left to right. And it's only going to cross your y-axis. Now, the one that confuses everybody is our undefined. So our undefined, that's only going through your x-axis. It's your vertical. Okay? So it's your vertical. So when we're taking a look at this, your undefined goes up and down. It only crosses the x-axis. Your zero is your left or right. It only crosses the y-axis. All right? Negative, as your x's are increasing, your y's are decreasing. Positive, as your x's are increasing, your y's are increasing. Okay? Those are the 4 most popular slopes. Now, what I'm going to show you, I'm going to show you a couple, most of it graphically, and just to see how it is. Because some people like to do the full calculations, and there's going to be times you don't have to. Just like what Daniel did. All right? So, let me zoom in. There we go. If you notice on the graph, there are 2 points. Okay, there's a point right here and a point right there. If you want the coordinates of the point, we're starting here at 0, 0. Then we're moving to the left, 1, 2, 3. So that means my x value is going to be a -3. And then we move down 1, my y value is a -1. If we want to find the coordinate of this point, I'll switch pens. Starting at the origin, I move over to the left 1 because it's aligned with that point. So that means I have my x value is -1. Then I go down 1, 2, 3, 4. So that takes me to -4. So the coordinate of this point is -1, -4. Now, we can find the slope one of two ways from here. There's really a total of 3 different ways. But right now, one of them is slapping us in the face. And that's called doing it graphically. That's where your rise over run is going to kick in. So you are going from one point to another point. So if I want to, it's almost like you're giving directions from your house to a friend's house. So if I live in the city, even if you live in the county, there's always some kind of street somewhere around there. But let's say we live in the city and we have city blocks. So I'm at my house here at -1, -4 Palmyra Street, right? And I need to get to my friend's house who is at -3, -1 Wright Street, even though you have to turn left. So I can't, these boxes is like representing someone's house. I can't walk through someone's house just to get to my friend's house. You can't do that in Baltimore or Philly. Not a good thing. You want to live to go see your friend, right? So what you're doing is I'm making a triangle. You see how everything, we talked about distance formula. We did a little bit of the Pythagorean theorem because there was a right triangle. Okay. Now we're talking about finding the steepness of a line by looking at triangles. Okay. It all comes together. So I'm going to go up 1, 2, 3. So from here to here, I went up 3 units. That was my rise. Now, from this point, right here actually, I'm going to go over to the left 2 blocks, 1, 2, to get to my friend's house. Since I went to the left, it was 2 units, and I went to the left. Since I'm going to the left, that's my negative. Okay? Going to the left is going to all the way to -infinity. Going to the right is going all the way to +infinity. Oops. About to throw my laptop on the right. Okay? Going up, that's +infinity. And coming down, this is going all the way to -infinity. All right? How are we doing? Okay? I think you guys are just here for the entertainment. So, keeping in mind, we have our rise over run. Our rise, which we said was up 3. So that's a +3. Our run, we went to the left. So that's a -2. So your slope, your gradient, your steepness is basically a -3/2. So this is the other part that gets people. 3 over -2 or -3 over 2, I'm going to write the word or. When you have a negative slope, you're making either the numerator or denominator negative, not both. Because if you make both of them negative, a negative divided by a negative gives me a positive. So you're making your slope positive when in fact it's really negative. Okay? Taking it all in? All right, nursery. All right, good. When do I go live normally? Well, Daddy of 4. Because I was about to call you Daddy, and I'm like, that's just not right. Okay, so Monday through Thursday, I'm usually on at 9:30 p.m. Eastern Standard Time. Fridays at 1 p.m. and Saturday and Sunday at 8:30 p.m. Yes. Okay. You like the negative? Yeah, so do I, Michael. So do I. It just didn't sound right, but hopefully you get that. But if you look at my profile, I usually have my schedule pinned at the very top, just in case anything should occur. All right. But I usually like to have my negative pinned to the top because I'm so used to doing the rise first before I do my runs. That's just why it is. But here's the best part. If I was here and I said, okay, let's go down 3, it'd be like 1. Well, let me start here. Let's go down 3, 1, 2, 3, over to the right 2, 1, 2. That takes me right back home. Okay, so if I started at my friend's house and I need to go back to my house, something was going on this side of the street. I said, nope, not going that way. So instead of me going up 3, I can go down 3, 1, 2, 3, and then over to the right 2, 1, 2. So it will still give you some teachers like for you guys to draw a rectangle. So that will give you your rectangles. What grade do I teach? Well, I used to teach. Right now I tutor 7th through adults. So I have Algebra 1, Algebra 2, Geometry, College Algebra, Pre-Calculus, not that AP Pre-Calculus stuff that they're trying to throw on us. The verbiage just throws my mind off. Maybe next year, but just not this year. And then anything intermediate intermediate algebra that happens at a community college. And then ASVAB and GED as well. Okay. Yep. We could say 10th grade and above. Yeah. All right. So, but sometimes I take some younger ones if they are on point. I do not do babysitting. I'm just letting you know right here and right now. If you need tutoring from me, I will walk you through anything. But if you want me to babysit your child, no ma'am, no sir. All right, so I got 2 more examples and then we are done for tonight, okay? I was like, you guys are making it fun tonight. Or maybe it's because I've been tutoring all day and I'm loopy. And I had a student that said, oh, Ms. Audrey, I have a test tomorrow. I don't know what teacher gives a test on a Monday and it's the last week of school. Really wanted to slap that person. But anyway, here we are. Okay, so what kind of slope do we have here? How do you graph polynomials? It depends on the polynomial. What do you want? You want linear, quadratic, cubic, quartic? What we got? Good. All right. Yes. Extraneous solutions. All right. So cubic. Okay. So you know you're going to have 2 humps, or you're going to have a double 0. because cubics always have like two humps. You always have like one less than whatever your polynomial is. Yes. All right, so we have a lovely positive. They gave us two of our points. Okay, so they gave us this point right here. Doesn't really matter what it is. They gave us this point right here because we're not looking at the length. We're looking at the gradient. So if you want, we can start at the bottom. We can go up 2 units and to the right 1 unit. So if we were to do rise over run, what would my slope be? C4 is saying up, rise 2, run 1 to the right, which is 2 over 1. Do we agree? Do we agree? Okay. Bundles of blessings saying 2. Yep, we can simplify it. 2 over 1 will give you 2. So we agree, we agree. Yes, Hadi says yes. Beautiful disaster. What? You're not a disaster. Just beautiful. That's yes. Nurse Green, yes. Michael, yes. Reed, yes. All right, good. So, not so strenuous, right? This would have taken a class, I think we did it for like 2 class periods. And each class period was like almost 80 minutes. The pain. Right? Rise over run, yes. So you thought you start at 0? True, when you're graphing the points. But right now we're finding the slope, and they gave us the 2 points. They gave us this point here, and they gave us this point here. So we want to know how steep is this line based off of our slope. Yeah. Yes, it'll be awesome if it was this way, right? So if you want, you can rise up 2 and then run to the right 1. When you rise up, that's going to be positive. If you go to the right, that's going to be positive. So my slope will be 2 over 1. Gotta unzoom a little bit, or a lot. If you went the other direction, okay? So if you start here and you went to the right 1 and then you went up 2, you're still going to have the same placement. Because no matter what, this is going to be your rise, and this is going to still be your run. Run goes left to right, rise goes up or down. Okay? When do we need to use the formula? We could. All right, awesome. We can use the formula right now. Yep, you'll just pick 2 points of your own. There you go. So this is how you pick points. Michael, thank you for saying that, because that's another thing, because people don't know how to pick a point. Now, I'm going to use, actually, let me use this other one. Let me use this last one. And then I will show you how to do it algebraically both ways, both graphs. And then we're done. I feel like I need like an affiliate with Scotch tape. Scotch tape, how it saves my lives. Yeah. All right, something's crazy. There we go. Whew. Okay. When you look at your graph, you want to pick, and I'm really going to zoom in, like this is going to be obnoxious. Yes, they gave us 2 points, but notice how they're intersecting. They're basically, you see this box here, this box, this one, and this one. There's like 4 boxes, and there's one point that's meeting one of its vertices. So if I'm looking at the line, I want to see where the points are going to meet. Like right here is one. And then if I come up here can be one too. You see how it's like right in the middle of the graphs? So this point right here on the x-axis, that's like halfway, but then you're dealing with halves. Same thing is happening up here. Yes, they gave us 2 points, but I'm traveling along the line. This one is a pretty good one because it's intersecting there. Here is another good one. And also up here is another good one. All you need is 2 points. That's all you need, is just 2 points. So I could find the slope with these 2 points going up 2 over 1. Or I can find the slope using these 2 points. 1, 2, 3, 4 over 1, 2. My rise was 4 and my run was 2. 4 divided by 2, or simplified, will give me 2. So it doesn't matter which 2 points, as long as you see 2 points that's on the graph, that's on the line. Okay, that's what you try to shoot for. Yep, and you can do it ratios. Exactly. Is intermediate algebra? Yes, it is, HB. How you doing? I'm sorry, it took me a while to answer your question. All right. Okay. So as long as you get 2 points that's on this graph, all right, it will give you those similar ratios. So 2 over 1 is the same as 4 over 2. Okay. And if we have to go as far as 6 over 3, we can do that as well. And that'll be this point down here. Okay, so I would go up 6 and then over 2, something like that. Okay? All right. Polar? Oh, yeah, I'm not doing that tonight. But I'm getting to know that a little bit well, Nick. Getting to know that a little bit well. Now, someone asked, well, when do we use the formula? So let's see. Let me get the coordinates of these points. I know I didn't want them before, but now I do. So I'm starting here at the origin. I'm going over to -2. And then I went up 1. The coordinates for this point, I'm at 0. And I stayed on 0, but I went down 1, 2, 3. If I want to use the formula, and the formula, you can do it one of 2 ways. You can do the traditional, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But did you know you will get the same exact answer if you did, my y1 minus y2 over my x sub 1 minus x sub 2. Okay? We're so used to doing it this way. And this is what screws a lot of people up. So we have our 2 points. So our first point was -2 and 1. Sorry, I'm writing on my tape. And the other point was 0, 3. Okay, since this was our very first point that we got, this will be my x sub 1 and my y sub 1. Since this is the second point that we got, this is my x sub 2 and my y sub 2. Once we got that information, we're going to plug it into the formula. So your y sub 2, you have your 3 minus your 1 over your 0 minus a negative 2. Okay? The formula is always originally minus. So if you're substituting a negative, you put a parenthesis around it. Like just make it a habit. Okay? From here until you get used to seeing. Because this is actually going to change from a minus a negative to just plus. Because when you minus a negative, it turns positive. So in fact, this is going to be 2 over 2. Okay? 3 minus 1 gives me 2. 0 plus 2 gives me 2. So it gives me a 1. That's weird. That's really weird. 1, 2, 3. Oh, that's why. That 3 is negative. And you probably were trying to say that to me. All right, so that makes sense now. So this should be a negative 4. There we go. Now we're cooking with gas. So this is actually going to be negative. Because I was like, why am I getting a positive? That's weird. So negative 4 over 2 gives me negative 2 over 1. Okay, thank you, Ash. I see you now. All right. And is that Sai? Thank you. All right. Yeah, I'm not doing vectors. Okay. Good. All right. Now, let me show you. We have the same points, but instead of trying to go from right to left, we just go our natural way, most of us, from left to right. So you have your y1, which is 1, minus your y2, which is a negative 3, over my x, which we have a negative 2, minus my x sub 2, which is 0. So when you minus a negative, it turns positive. So that will be a plus 3. So that makes that a 4. And negative 2 minus 0, that also gives me a negative 2. So 4 divided by negative 2 gives me negative 2. You get the same answer. Okay? You get the same exact answer. So my thing is, if you are used to reading from left to right, why not do the same thing for slope? This is what happens to people. They get lost after the y and they go negative 3 to 1, minus 1, and then they do negative 2 minus 0. So if it mixes you up, why not do this? Do the difference of your y's, go from left to right. Difference of your x's, go from left to right. You're going to get the same exact answer. Okay? That's you? Yeah. And you're not by yourself. You are not by yourself at all. Because sometimes you're like, oh, wait, did I use that x again? And did I do that? Yeah, so you are not alone. You are not alone. Okay, so if you want to, you can do it that way. Some people say, well, you're going to have to deal with the negatives. I'm like, it doesn't matter. You're still going to have to deal with the negatives. You're still going to have to simplify, just like any other time. Can you label the points any way you want? Meaning which one's the first point, which one's the second point? That doesn't matter. But it is always going to be X then Y. That's important though. Okay, so if I said my first point was 0, -3, and my second point was -2 and 1, yeah, that's fine. You'll get the same answer. But do not say, oh, my first point is 1, -2. That will be wrong every time. Okay? All right. Okay. How are we feeling? Okay, so just a little introduction with slope. It's nice to see that although we were looking at distance, which was from one point to the next, and then we looked at the steepness, which deals with slope, there's a lot of similarities. You know, if you look at the equation, the line, this is part of, let me just show you. It's so much easier. So we looked at a formula, which is that y2 minus y1, x2 minus x1. That's the same thing that was going on with the distance formula, but we were squaring it. So we were looking at the change of our y's squared plus the change of our x's squared and taking the square root. And there are different equations of the line, which I'm going to do a little more linear stuff this week because some people are taking their ASVAB, and that's that part that they score a lot on. Like the ASVAB and the GED, they score a lot on the slope stuff, on the linear. They give you more. These are like 4-point questions on the GED. Okay? Anything that deals with linear equations. And we had one person that took that the ASVAB, and he said the same exact thing. That was like a couple weeks ago. And he said the exact thing, like there was a lot of linear stuff that he had to put in there. Not too torturous. Okay, good. Okay. Okay, yes, please. Okay. So can I explain square roots? What do you mean? Like the breakdown of a square root, or what we got? So you have a test on the 25th of May, and you have a phone number? Okay, that's interesting. I need help with this. Okay. All right, so definitely this week we're going to be working a little bit more with the equation of the line and also graphing the equation of the line. And we're going to look at the equation of the line 2 different ways. We're going to be looking at slope-intercept form and point-slope form. Those are huge. And looking at how to find a line that's parallel and perpendicular to a given line or point or all that stuff. Okay, so that's what we're going to be working a lot on this week. Okay, all right. So you started summer session for your algebra tomorrow? Okay. Now, here's my thing. If people are starting, that does make sense. People are starting their summer sessions, don't wait until you get into a hole. You have someone here that can help. And she's just as crazy as anything. But no, seriously, don't be like, yeah, I can do it. And I'm like, you probably can. But it'll be so much easier to say, you know what, I tried this and yeah, I got questions. And then you seek assistance instead of you waiting 3 or 4 weeks after you've done things and you just basically want to give up. And that's when you're trying to seek help and ask for a little Hail Mary type of thing going on. So ask for assistance early. Please DM me. And if you don't like me and you want someone else, I have plenty of friends that are tutors that'll be more than willing to help. Okay? I don't. During my spring semester, no. But guess what? You still got me now. You got me now. You can't get rid of me. It's like, you can't get rid of me. Not at all. Can you show the equation for finding midpoints? Sure. Oh, actually, it's right here. Boom. Yep. So you got your distance formula. You got your midpoint formula. Now, if you guys want copies of my notes again, you can go to my profile. And what happens is it's called Audrey's Notes. It has like a whole collection of all my notes from like February 5th when I first started doing all this, up to, I want to say, about 2 weeks ago. And then I started on book number 4. So books 1 through 3 is done in the books out there ready for you to purchase. And if you want one of my notebooks, yes, you can go on Amazon for right now. I'm kind of waiting to see what it looks like. I don't want you to invest money in something and that's just me. Maybe I'm just a real softy when it comes to business, but I like to make sure people get quality before they start purchasing. But if you want a math notebook, I do have the digital version online, Audrey's Notes is digital on my website. If you want copies of the math notebook, that's on Amazon, and I do have a link in my website to take you directly there. So you can purchase your books there. And if you are saying, hey, I just want to do a course this summer, I'm going to do a live course dealing with all the basics of the basics, like adding, subtracting, multiplying, dividing, fractions, decimals, working on order of operations, working on, exponents. I just had a brain fart for a second. Exponents, and just really digging deep with all of those basic concepts that we haven't seen since we were a fetus. And now all of a sudden we're supposed to because you're trying to take a class. So definitely be on the lookout for that. Again, subscribe to my YouTube channel so you can get access to all of the lives. And it's a really easy and a free subscription. I'm not famous yet, so, I'm not trying to nickel and dime people. I just really want you to go after your dream and don't let math be that barrier. As I said, my live schedule is Saturday and Sunday. I'm here at 8:30 p.m., Monday through Thursday at 9:30 p.m., and then 1 p.m. on Fridays. So if you need me for tutoring, I'm here. I'm here. Okay. If you do want to take the risk and just like, you know what, Audrey, I want to just buy your notebooks. I want to support you. I love you. All right. So you can go to Books by Audrey Codner. Yes, she's got a link. Okay. And there is a hyphen. I almost forgot about the hyphen. Let's put in a hyphen. Okay, so Books by Audrey Codner, that is my own bookstore. So anything that I'm selling books-wise, that's where I'm going. And if you want to get an on-demand course, I created a course for GED, another one for ASVAB, Algebra Foundations. If you have a child that's going to graduate from 8th grade and they're going into 9th grade and they're doing Algebra 1, this is a great something for them to do during the summer. And I know they're going to be like, oh, I don't want to do anything for the summer. Okay, whatever you want to do. But there are videos there, there's practice sheets, and there's a couple quizzes on there. So you can just go to my website, ACG Math Tutoring, to get access to the course. Now, last bits, I praise people when I meet them. So one of the things, not a problem. Is it going to be on TikTok? I don't know, Nixon. I'm not sure. I'm debating, but I will make a decision this week on where is it going to be. If it's going to be on TikTok or it's going to be on Zoom. I don't want people just randomly sneaking in. I want people to commit and to do it. We're going to meet twice a week for the summer months. And I just really want to make sure that you're given some time to ask questions, given some time to I don't know where this came from and where that come from. I'd rather have interaction instead of you trying to type. Sometimes I'm not a texter. I'm the type of person I'm Just girl, just call me on the phone. Why are you texting me? So that's the type of person I am. So if you're going into nursing, make sure you follow a blessed RN. She has like a quick way of how to do your dosage calculations without doing way too much math, and it's always accurate and on point. She's an RN as well, so like if you want to follow a blessed RN, she's great. There is another person, Impact Math 19, Miss Taylor, and she does TEAS test, ASVAB, and GED. It's best to get more than one person if you're trying to prepare for those exams, because you see, I'm here in the evening, she's there mostly in the afternoons, and sometimes she comes in the evening as well. So it's just nice to have another person to learn from, okay? Then you have a chemistry tutor, Professor TK. She's awesome. She's live on Tuesdays and Thursdays at 10 a.m. Eastern Standard Time. And the way she breaks down concepts and how she balances those equations, that's not me at all. But she does it with such great ease, and she knows how to break it down to you. And then if you want to learn how to add, subtract, multiply, divide using an abacus, right? Remember those little bead things that you do with accounting? You're like, how do people do that? You should follow my friend Lynette. She is amazing with this. I mean, she's modernizing it. She has books on TikTok Shop, on Amazon, and she's always like, showing things out. I love when she calls her midnight math section, because usually that's when I have time to actually watch and drop in. And then if you have younger ones, if anything, my friend Nancy, she helps with homeschool. If you're thinking about homeschooling your little ones, like pre-K to kindergarten, definitely take a look at her stuff, as well as she does tutoring for the younger ones for reading and math. And she's actually doing a math lab this Sunday or this summer. So definitely take a look for online elementary tutor. Her name is Nancy. She's amazeballs. Okay. Yes, I'm really pulling towards that, Nixon. I really am. I think doing a Zoom will be a little more intimate. Hey, TK's here. So, hey, right in here. So, if anything, if you want to ask her, make sure you follow her. Okay. I tried to join Miss Taylor's live last week, but was denied. Michael, what'd you do? You seem like a nice person. Oh, for paid subscriptions. Yes, she has a couple of those. I think, was it an evening? Because I think her evening ones, she's doing paid subscription, but I think her day is still free. Okay. All right, cool. Yeah, it was yeah, I think her evening ones are paid subscriptions, and then her day ones is the free ones. I know. It's like, but see, to do all these things, it takes a lot of work to do the prepping. And Michael, you know me. You've been here since the very beginning. You're one of the OGs of, of my peoples. You and a couple others. And it takes a lot to prep. And especially when I was doing it like twice a day, that wore me out. And it takes a lot to prep and to prepare. I mean, some people can just, get some. Okay, I just so happen to have some of these to get ready for my other kids for tomorrow. Like, you can easily print some of these papers off online and just go through papers. But when you try to strategize and really get the best out of it, that's when it gets exhausting. And I know we as educators, we generally don't ask for money. We do the education because we love to teach. We love to educate. But we got something called bills, taxes, I don't know, eat. That just kind of gets in the way, But that's why, some people, we just want to start charging, because it's a great value. Some of you guys are taking this information and growing. So we need to grow ourselves. We're basically using our abilities to break these concepts down for people. So that's why. Yeah. Yes. All right, so sorry for being very preachy, but this was actually kind of fun. So if anything, definitely have the people to follow. Make sure you follow these guys. And if you have any questions, like people ask me some very interesting questions, but if you do have a question, I always say, ask it. You know, if you're thinking about going and getting your GED and you're scared and you don't know how the test is designed, just ask me. You know, I will definitely give you the truth answer of it. You know, everything is not being graded at the same level. You have 1 point questions, 2 point questions, 3 and 4, but you don't know what it is until it's graded. And I'm going to tell you right now, anything linear or factoring, that's going to be a 4 point question. And you want to hit those 4 point questions. All right. Yes, you have a blessed day too. Yes, not a problem. It's always a good time. It's always a good time with you guys. But if anything, yeah, please don't hesitate. Just give it a call. All right, so I'm going to wrap this up. I'm going to wait my next 3 hours to download this and then put it up on YouTube. All right, so I will see you guys tomorrow evening. We're going to continue on looking at linear equations. We're going to be doing some graphing and looking at the equations of the line. All right, so take care. Have a lovely evening, and I'll see you tomorrow night at 9:30. Bye.